Hey guys, we are live. I'm Mohit Yadav and I teach in Scalar Academy. I'm one of the instructors here. Prior to joining Scalar, I have been working in the coding industry for almost a decade now. I was leading team at Nutanix and Hotstar earlier. So I'm going to be taking this session today, wherein we'll talk about debugging prod issues. The theme is debugging prod issues, and we have taken multiple sessions around this. We started off with discussing on a theme of how senior developers look at prod issues and how a junior developer looks at prod issues. Then we also looked at client side and backend side issues, and then there were couple of other sessions also where we spoke about how to debug a particular application. The latest one being uh, seeing production issues from a lens of a backend developer as well as a front-end engineer. And we spoke about the importance of matrices, alerting, uh, monitoring, and basically setting up good practices where you will can where you can have uh, you know uh, where you can debug applications easily. Today we are going to look at the same issue from a lens of a infrastructure engineer, that this particular problem is uh, can arise at an infrastructure level as well. So we are going to discuss what kind of issues can arise at an infrastructure level, and also what can be the possible fixes and what are the best practices that you can take up at an infrastructure level. This is going to be a 30 minute to 45 minutes max session. Uh, Initially, I'll talk about a couple of things, and then whoever is interested can pitch in and comment about if you have any questions, if you have faced issue in production and want to discuss about that, or if you want to me to talk about a specific question, you can also talk about. I can also talk about that, right? So meanwhile, while I'm talking, please keep your questions flowing. I'll keep an eye on the comment section, and if there is a relevant question that needs to be answered, I'll pick up that question and answer that for you. I hope that works for everyone. Yes? Can I have a quick yes? If everyone is aligned, we can quickly get started. I think there's some delay between you typing the messages and me getting the feedback. Anyways, let's get started. So I want to start by looking at basically the issues that can be uh, solved in an infrastructure level. What I mean by an infrastructure level is that you can come out of an application code. Now, what is an application code? The code that you write in Java, Python, C, C++, Node, anything like that, right? So, any language that you take, you deploy that particular language on a container or a server, right? That server can be very well be your laptop as well. So you deploy your application there, and how it exactly, how is this particular server responsible for answering all the requests that your clients are generating? We're going to look at those aspects. So the first thing that typically we need to take care when we are, you know, when we have a decent enough scale, basically forget about scale as well. When we have more than just one instance, the reason can be that we want to avoid single point of failure. We want to that can be scale, or we want to avoid failures in general. To bring in more resiliency, we need multiple servers, multiple application servers to talk to the client instances. So as a result of it, what we end up doing is that we have one load balancer. Behind the load balancer, we have small instances, right? And these instances are running your application code. So these are the instances that I'm calling, which are running application code, are called app servers. And from time to time, these application servers needs to get a new code, right? This new code that these instances needs to get is basically because we want to is primarily because we want the service to evolve with time, right? There might be new set of features that you want to add to a particular service. There might be a bug that you have fixed in a new service. So the first problem that comes in that if I have a load balancer and behind that we have multiple services running. Let's say there are four instances of application servers running. Then how do you even deploy the new changes? If I to help you visualize the problem, if I just turn down the instances and copy the new source code and build it and then run it, there'll be downtime, right? Because I'll end up killing the. Let's suppose. Let's take an example of Java, but we can extrapolate it to any other language as well, right? I think almost every language will need to get these things correctly, right? So the steps are that I'll kill the old process. I'll from Git I'll pull the new source code. I'll build that particular source code, and then I'll after the build I'll get some executable and I'll run that executable, and my new code will start running. Now I SSH into all the four. This is the brute force way, right? I'm telling you the brute force way, and then we iteratively build a better product or a better deployment strategy. So I SSH into all the instances and I kill the processes. What happens now? Now my service is not available because any request that comes in will see that hey, the containers, all the containers are down. There were instances of four instances or four containers. I have turned down all the four containers, and now I am not available to take any further request. So that brings in downtime, right? So I need to avoid such kind of a downtime. One strategy that I can, adopt is that I can do it as a rolling deployment. That means I'll instead of four services, instead of killing four four application servers or four applications at the same instant, what I'll do is I will uh, just one second. Yeah. So what I can typically do at that particular stage is that I can turn it down in one instance. Three instances are still running the older code. The newer instance, however, in the newer instance or the newer, I'm calling it a newer instance because this is the instance which will be running the new set of code. So I go to this particular instance, I turn down the application, pull in the new code and build it and then start it again. So now I have two versions of applications running behind a load balancer. One is basically catering to the newer set of requests. The other is basically will basically have the older application code. So at a load balancer level, it might have very adverse effect as well. It works like my application is not going down. The pro of this particular approach, if I look at the pros are that my application is not going down. So there is a very less downtime because uh, once the new code is deployed on first instance, then only I'll go to second instance and I'll keep on doing that. So that will ensure that okay, my applications are not going down, right? So the entire application is not going down. However, this introduces one new class of bug. That bug is that there are two versions of applications which are now running. Imagine that I have a new code or new source code written, and I deploy that particular source code, and that is now running in one instance. That new let's call it V2. That V2 source code is running, and the other instances are running a source code of V1. And if the changes are backward incompatible, that means that there is one API. Uh, just giving you an example, what I basically uh, imagine that just one second, I'm just gathering my thoughts. Uh, yeah, so there are two sets of application running. One example that I can give off is that there is a API in which you have added, let's say, one more column. Let's say the API was get user profile, and in this get user profile, The earlier version, V1 version, was returning name and date of birth, and in the V2 version, it is running name, date of birth, and email address. Now, since my clients will expect email address to be a part of every subsequent request, and if the request goes to the earlier version, it will lead to an error scenario, right? So I want to get rid of such kind of things, right? So what I can do is I can try for something called as a blue-green deployment. Now, what is a blue-green deployment? I hope this is clear to everyone that what is the exact problem here. Now, to get rid of this problem, we have something called as a blue-green deployment. In that particular blue-green deployment, how that particular blue-green deployment works is that you have four sets of instances already running beneath, and then you start another four instances, parallel instances. You won't do anything to these four instances. Add four more instances to the infrastructure to the start up all the four instances, attach these four instances to the load balancer, and once all four instances are in healthy state, then turn off the initial four instances. So these at one time, there will be a time where all the eight instances are up, and then you'll turn off the older instances. Only the live new ones will be there. So you're removing the problem of that every instance is basically catering to all the, like, you're supporting two versions within the same API. That is not going to happen, because the moment all the newer ones comes alive, you'll just turn the older ones off, right? Now there is uh, one case where your request might drop off. That case is, imagine that your V1 services, or the older set of services, were processing some request, and while the new set of instances came alive, that is the time the infrastructure team or the infrastructure management system decided that it has to turn down the older set of instances. If there are any pending requests on those older set of services, and I get a trigger that, hey, just terminate all the instances, then I get into a scenario where those many pending requests will be dropped. Now, I can do something to avoid this as well. What can I do? We have something called as a connection draining feature, right? So what this connection draining feature ensures is that you can set some delay based on your average time, or P99 metrics that we have spoken about in earlier sessions. You can measure your P99 metrics and come up with a threshold that, hey, 99 percentile of my request uh, completes in, let's say, 10 milliseconds or maybe 100 milliseconds. Then I'll give a buffer of 100 milliseconds that terminate the instances only after 100 milliseconds. And as soon as you receive this particular trigger that, hey, the newer set of instances are up and alive, then stop receiving the new request. So I'm doing two things here. One, I'm not receiving any request as soon as I get a trigger. The second thing that I'm doing here is that as soon as I get the trigger, I have X amount of predefined amount of time left with the instances to process the entire request that are there on that particular system and respond back. Because after that, those set of instances will be set for termination. I hope that makes sense to you. That was the first point I wanted to discuss. Is that clear to everyone? Can I move ahead to my second topic, which is circuit breaker? Sounds good. I hope it does. Let's go to my second important topic, which is circuit breaker. This was all about what I wanted to cover around deployment. The second important infrastructure problem to solve is that what is a circuit breaker. Now, circuit breaker will make sense when you have multiple, okay, let me put it this way. Let's say you have one request coming to your system. To complete that particular request, your the first box that receives that particular request, right? That to complete that particular request, you need to call multiple services, right? I'll give you an example. Let's say you are landing at an Amazon.com page. Now, at an Amazon.com page, there are multiple items that are shown to you at your home page, right? Some of that is let's say content which is personalized for you, maybe items based on your past previous order history or something that you have browsed and not really bought it. So there might be some items related to that, and those are classified in different rows, right? Uh, if Amazon is showing orders which are just related to your past history, it will like it will say that in the row description. And if it is something like if it is launching, let's say OnePlus, whatever is the next version, I don't know. I think OnePlus 8. If it's launching, let's say OnePlus 8, then it will also show some type of a promoted content, right? Apple, let's say it's Apple is launching iPhone 12 s, then it will show Apple 12s exclusively available on Amazon.com. So these kind of things are actually taken care at a backend level. What happens is the request from your mobile phone or your browser will go to one service. That service will break this particular request and call multiple other services. It will call recommendation service. It will call order history service. It will also call the editorial tray service. Now, as you might imagine, that the SLA for each service might differ, and the total latency, if client has to do something like this, the total latency will be defined by the slowest system which is responding, right? So, what if, let's say, to generate recommended content, that service fails? What will be the impact? Can you imagine that the impact of such having such kind of a service would be that it will degrade the overall experience of the homepage? Why it will degrade the experience? Because the service which is aggregating the response from recommendation service and other service will be degraded, because one time like it is actually at the max of recommendation plus order history plus editorial content. So if one max increases, the overall time also increases. But as a owner of this particular aggregation service, my job is to not degrade if performance of my dependent service degrades. To avoid this, and so this is one problem. To avoid, I'll come to how to avoid this. Another problem is, let's suppose I'm this service, this particular aggregation service, I'm calling it. Let's say it starts getting multiple requests. Now what happens is, it since it is getting multiple requests, it needs to send this particular request to all the other services. One service which is already taking lot of time, and I'm just bombarding that service with other requests. Ideally, if I slow down the rate on this particular service, my system will be self like if it's a self regenerating kind of a system, it will be back to normal. It will be if it's a self balancing kind of system, it will come back to normal. Now, to be able to come back to normal, this particular system needs to I need to basically make sure that the once when this particular system is not performing to my benchmarks. It can be a latency benchmark, or it can be number of 4xx or 5xx benchmark, or it might be that the number of requests this particular system is experiencing is huge, or the latency is not in the expected range. Then what I can do is I can tell my aggregation service, hey, this particular system that I was gated on, I wanted to get a reply from this particular service. If this system is down, then do not send any request to this particular system for a certain time period. Why? Because if I just start sending the if I just keep on sending the request to this particular system, which is already in degradation state, things might get worse and it will affect my overall system as well. The aggregation service will also start seeing lot of errors, and I will never be in a position to give certain kind of a response. So whenever I'm calling a dependent service, I need to ensure two things. One, that the response, if the response is not coming in a given amount of time, this given amount of time is basically decided by me. If it is not coming within the given amount of time, I will respond back with an error, right? And I'll treat this particular response as an error. I'll make a count of how many such errors have come in the last, let's say, 5 minutes or 10 minutes, or basically a moving time window. If that particular error is greater than the threshold, then I'll open the circuit, right? So in electronics and so in electronics, you might have heard about circuit is open, circuit is closed. When the circuit is open, no current flows through the entire circuit. When the circuit is closed, current can flow through the entire circuit. So similar to this, if the circuit is open, there won't be any request that goes to my dependent service. If the circuit is closed, there is normal flow of data exchange between the two services. What it helps me in is that it helps me first of all define a SLA for my service. I have an aggregated service. It might depend on multiple dependent services, but still I using a circuit breaker technology, I can provide a service level agreement or an SLA for my services, how many errors I can give, how many what would be the latency of an overall system. Those and all I can give using a circuit breaker, and I also protect my service from a cascading failure. So, for example, personalization system break, and then because of those failures, my aggregation service also breaks. So I also protect myself from a cascading kind of a failure using a circuit breaker. Popular examples of circuit breaker is Hystrix. It's a Java-based framework by Netflix open source community. The other one are Nomad, which basically sits along with your infrastructure. So there is no need to add a dependency on your code. Plus, uh, these are actually your application can be written in any code. With Hystrix, the application must be in Java. You need to add this particular dependency of Hystrix in Java. Java jar files that you run. But otherwise, both the systems work equally well. I have worked on both the systems. I personally prefer Nomad because it gives the application developer the extra flexibility of choosing the language of your choice. So both the things that we have looked at till now, deployment and circuit breaker, are actually polyglot in nature, meaning that they don't depend on which language you are choosing to deploy, which language you're choosing to deploy that particular application. It can be in any language. I think somebody pointed out about service discovery. I think Rahul. I'll talk about service discovery as well, right? So um, imagine this, right? Let's say your application needs to talk to a database. Now, database can have multiple data nodes as well. How do or database is not a good example. Uh, let me explain using the same example, right? You have aggregation service, you have multiple services, personalization service, order history service, and maybe the editorial service. Now, if the aggregation service needs to talk to the personalization service, there are two ways of doing that, right? One is use a load balancer. It can be a network load, application load balancer, network load balancer, if you want to go to a network layer and communicate on that. Or it can be a classic load balancer that AWS provides. But regardless of whatever load balancer you choose, if you are on AWS or if you are on AWS cloud, or if you are, if you're deploying it by your own, then also this load balancer can be in two places. Either it can be a public facing load balancer, meaning that it can accept traffic from the public or the client, or it can be an internal load balancer. Now, if it's a public facing load balancer, uh, the request from your aggregation layer, once it reaches your aggregation layer, will again go to public facing load balancer, fetch the IPs, and then finally be routed to an internal service box. So there are two hops here, right? Request from a client, request that originated from a client goes to the load balancer of, let's say, Amazon.com. From Amazon.com load balancer, it will be routed to the aggregation service, some aggregation server. From aggregation server, it will again be routed to one public facing load balancer. It can be, we'll see the case of internal load balancer as well, but it goes to again the public load balancer, and then again it comes to the final service that you have, the personalization service or any other service that I listed out. Now, what is happening right now is that your once it passes the public layer and reaches your internal network, and then again you're going to a public network, that makes the request very susceptible to attacks, and it's a security vulnerability. Plus, the second demerit of this kind of an approach is that you could have had a one HTTP call. The internal aggregation service could have just called one more service, for the personalization service, if it had the IP of that uh, particular service. But since it does not have, it has like only one option left, which is to go through a route of load balancer. Now, some might argue that this public load balancer is I'm just exaggerating it. We can have an internal load balancer as well. Even then, we'll basically get rid of the security risk, but we will still have one more hop. The hop will be from the aggregation layer to the load balancer between my aggregation layer and my personalization service layer. So to avoid this, I need I can do two things. One is I can list down all the IPs of my service. I can list down all the IPs of my personalization service and add that in my aggregation servers list. The problem, however, of this particular approach is that once my uh, personalization server IP changes, I will then have to uh, redeploy my application, or basically have some way to communicate to my aggregation service that the IPs have changed. Now start using these IPs. Now this is an infrastructure headache, right? Because personalization service I don't own. Some other teams owns it, and they might or might not tell me that hey, we are redeploying it. Plus, it's a manual kind of a process. So what typically the way two services in a distributed architecture communicate is they use something called as a service discovery layer. Now, what is service discovery? In service discovery, you have a registry of all the services against the IP of those services, and then you have clients of these registries. So you have one centralized registry maintained, which contains the IP address of all the services that are available in the cluster of services that you have. Now you might argue that this is similar to if the aggregation service has to call this particular registry, then it is no different than calling a load balancer, because again this is a network hop. But in actual, this service registry makes you install this particular client, service discovery. This is service discovery server, which contains the registry. Service discovery clients are there on every server that is running. So it is the responsibility of service discovery client to fetch data from service discovery server. And this IP, whenever it gets changed, all the clients which are basically polling from the server will get to know that there is some change, and hence they will be able to call the new server automatically. Right? Consul by Harshikov provides service discovery. If you want to go and read more about any of the tools that I've told you, A good open source project would be by Harshikov. I would suggest everyone to please go and read through it. We have Consul, we have Vault, and Nomad. So these are some of the tools that you can go back and study. I'll take a few questions that are there, and we'll uh, then we'll conclude the session. Yeah. If you have any comments or questions, please post them in the comments. I'll be going through the comment section. Uh, Jenkins with a GitHub webhook. I think Rahul, what you are talking about here is the CI part of it, wherein whenever somebody uh, pushes something to GitHub, then you basically your Jenkins pipeline, which is basically an orchestrator pipeline which is basically used to orchestrate the workflow of your deployment and creating a deployment plus you're creating an image of your particular artifact. So CI part is that whenever somebody uh, pushes something to GitHub, then you should ideally build a image out of it. And once you've built that image, the second part is deploying that particular image. You may or may not want to deploy it. That depends on the business tool. Jenkins is one tool that primarily aids in CI. People do use Jenkins for CD as well, but we'll go. I don't want to go into details around why Jenkins is not the best fit for CD. We'll discuss. We'll have some other sessions around that. Uh, Differences between containers and instances. Basically, containers are nothing but uh, containers are basically deployed within an instance, right? They are small memory footprint. They are easy to manage and uh, basically very lightweight processes, right? That you can spin up into the instances. Uh, Shashank, I don't really get your question. Can you be more? Can you clarify what your question exactly means? How to prod issue with less or no debugging. I think what your question is how to debug a prod issue without less or no debugging. That is something I think if you're referring to at an application level, we have done a session on backend and frontend where we specifically talk about how to debug at prod issue at an application level. Logging comes at an application level. So right now, what I spoke about was primarily focused on the infrastructure level. How to debug. What you can typically do is, like if you don't want to, as Bhupati also spoke about distributed logging or distributed tracing. I've spoken about these concepts in the last class. I would urge you to, after the session, and uh, go and check the previous session. Yeah. All right. I think there are no further questions. So where is the uh, where is the backend debugging video? Please go to our channel and search for debugging prod issues. You'll find it there. There are three. This is basically the third session. So if you want to go and see the past two sessions, you can go to Scalar Academy YouTube channel and find that. All right. Yogindra, I am not sure which third method of deploying you are referring to. I In this session I've only spoken about blue green deployment and rolling deployment. The first one that I said was primarily the deployment, the brute force method, where you just kill all the servers and then replace it with a new one. All right, guys. Thank you all for joining in. If you have not subscribed to our channel, please do. Tomorrow we are going to have another session where we'll have where we'll have our founder Abhimanyu and Arnav Gupta from Coding Blocks uh, speak about different things. So we keep on we keep doing these live sessions on tech topics plus non-tech tech allied topics and general tech jam. So uh, please subscribe so that you get notified about new upcoming live sessions. Thank you all for joining in. Bye bye.